Welcome back. In the last video, we explored where AI is being used and how we interact with machines, the human machine interaction. Today, we'll be talking about the three domains of AI, which are data, computer vision, and natural language processing. By the end of this video, you would know what each domain does, to see them in real life, how they interact with each other, and maybe one of these might interest you for a mini project, because at the end of today's video, I have tried something new. I have given you three project ideas, and you could just pick one up and see for yourself how the different domains of AI function. Let's dive straight in. What do we mean by domains? A domain is simply area of AI based on the kind of information that it handles. That is the type of input that the AI model will get. So if the input is numbers in tabular form or otherwise, that is data domain. If the input is in the form of images or video, then that's computer vision. And if it is text or speech, that's natural language processing. Now you can tell for yourself that many real apps, rather most of the real apps, would combine two or more of these. Let's see how these domains actually work. So this is the data domain. Then I will draw the computer vision domain that will be overlapping this. And then I will draw an NLP domain that will again overlap these two. Now let us take some examples of apps. If we have a weather forecasting app, so that will be like data domain, because it will be taking input in the form of data, temperature, rainfall, all these are tabular data, and then providing output accordingly. But suppose I am talking about the face recognition app. It is using computer vision. And then I have a camera that takes verbal instruction. That will be a overlap of data and computer vision. If I am using Google Translate, then that is a overlap of data and natural language. And then suppose I have an app that identifies plants. That app will take input as the image of the plant. That will be computer vision. Then it will look into its database and find out what the plant is. So that data. And then if you have any questions, so it is answering the questions. That means it is using NLP. So that app is a overlap of all three: data, computer vision, and NLP. Now let's dive deeper into these three domains one by one. The first one is data. Data is basically working with numbers, categories, dates. The data could be raw as it is or organized in a tabular form. Basically, the AI model looks for patterns in the data that is presented to it, and it will analyze those patterns and try to make predictions for the future. So some of the examples include weather forecast or sales trends or exam analytics. So let me just talk a bit about how exam analytics would work, so that you can understand how AI model is identifying the pattern based on the data that it has. So suppose your teacher wants to know which subject you all are struggling in. So what they would do? They would look at the past exam results or test results, test scores that you have. And looking at that, if somebody has scored less in a test in a subject, then of course they are struggling there. If majority of class is scoring low on some subject or some topic in subject, then that means they are struggling with that topic or subject, and then the teacher can ask you all to study more, provide you extra classes. So this is how the exam analytics would help. What you need to remember is that it will take patterns and it will make predictions. That is how the data input is being used by the AI model to provide the output. Let us now look at how the data goes from input to output. The workflow starts with collecting data. Once the data is collected, it is cleaned to remove mistakes, or sometimes some data is missing, so an estimated guess would be made to fill up that missing data. This phase is very important because remember, garbage in, garbage out. If you give useless data, then you will get useless output. If you will give clean data, then you will get clean output. So once that cleaning is done, then sometimes the data is visualized using charts and other statistical methods and is used to train the model. The model learns patterns from the existing data, and once that training is complete, it will give the output for a new set of input that it has been given. The data scientists don't leave the model after it is live. They also monitor it whether it is giving output correctly. So if out of 100 times the model is providing incorrect output, say 20 times or 15 times, that is unacceptable. They will then refine the model. So wherever that error was there or incorrect output was given, they will provide the correct output and ask the model to correct itself. That monitoring phase is also very. Next, let us come to the second domain, which is computer vision. Computer vision teaches machines to interpret the input that is in the form of images and videos. The most important tasks that computer vision system would carry out would be classification, detection and segmentation. It will detect an object, it will classify it, and it will segment it. Think of segmentation like drawing boxes around them, or segmenting each pixel into parts like, say, road, car, person, or traffic light, or animals, right? This is how the segmentation of each image is done. Computer vision powers tasks like face unlocking, self-driving car, and reading the x-rays and images for the doctors, highlighting the suspicious areas in a scan. Now, computer vision is there to assist the humans, and it does not replace the expert judgment. So in a partially automatic car, if that is being used, then it is finally the human driver who will decide what action to take depending upon what the computer vision has detected. In case of healthcare systems, the doctors get the output from the computer vision system, but it is their final say that what is the actual diagnosis. So examples of computer vision system, as we discussed, face unlock, traffic sign reading, medical image support. There are tons of examples that you can see. So let's look into how the computer vision works. Now, images are seen as a grid of tiny squares called pixels. Pixels is nothing but short form for picture elements. Images are nothing but grids of pixels. Now, to just show you how these pixels you can imagine, let us look at a small video here. So here what I'm trying to do is I'm trying to draw a square. Here each of my pixel is consisted of 4 squares together. But in the second one, what I'm doing is my each pixel is that smallest square. So once the second one is also completed, you will see that the second image that I draw, the second square that I have drawn, that looks richer, isn't it? Why? Because the pixels are smaller, which means that larger the number of pixels, more richer the image. So how the computer vision system works is the model again learns the features or the patterns from many examples that you give it. Let's say the computer vision system should identify cats. So it will study lots of images of cats, thousands and thousands, and it will learn what features usually appear in the cats, like ears and eyes and paws, PAWS, not PAUSE. So then what is their shape and what body parts they have, what is the texture of their skin, what is the color of their eyes. And after being trained on thousands and millions of data, it will get better at recognizing them in new photos that it has never seen. Having labeled data makes it easier for the models to learn quickly. Labeled data, the overall image as well as the individual parts may be labeled. But whether you are using labeled data or unlabeled data, just remember that more and varied examples would be better for recognition. For example, you can see here in the slide that I have given images of cats where they are doing different things, they are in different surroundings, and their colors are different, the images are from different angles. This will help the algorithm to produce better results. And what does better result mean? It means that it will identify a new image of cat with higher accuracy. That was about computer vision. Next, let us come to the third and final domain, which is NLP, natural language processing. It focuses on language. So that could be a written text as well as spoken words. And mind you, language understanding is a core AI component, because computers have been around, supercomputers have been around, expert systems are being used since the 1980s. So what is the difference between those expert systems and the narrow AI systems that we have? Natural language processing. It converses with us as if it can understand whatever we say, and that makes it easier for us to use those systems, and it can find varied applications as well, because not everybody is adept at typing and communicating with the computer. How the NLP works? Some of the most common tasks are translation, chatbots on websites and apps, summarizing long passages, detecting the mood of a passage, spam filter. So these are some of the common examples of NLP domain, and these are being used by voice assistants, then email service providers, all the financial applications. So these are all using your NLP. Next, let us look at how NLP works in these AI systems. The NLP algorithm first breaks down the sentences into smaller pieces, words, subwords, which are called tokens. Then it looks at context, the words around a token, to decide its meaning. And once it has been trained on large amount of, the NLP model will learn grammar and common word relationship and how the sentence construction is done typically, which will help them in understanding human language, making translations, answering questions, or even summarizing large text. In tokenization, text is broken down into smaller units such as words or sentences. If it is a paragraph, it could be broken down into sentences and then further broken down into words. For example, I love AI. That would be tokenized into 3 different words, which is I, love, and AI. So let us get a glimpse of NLP in action. I have here this text and I will try to create tokens from these words. I have done this using ChatGPT because that is an AI tool. GPT, I straight away asked it to break down this paragraph into tokens. As you can see, there are total 75 words that have been created. Now here you can see that it has even repeated words. And is there, then and is again there, right? So what we can next do is we can delete the repetitive words and also the stop words. Stop words are like to, and, for, is. These are typically extra words. Extra words as in without these words also you can understand the context of the sentence. After stop words have been removed, then there are 35 words. So this is how it works. So now that whole paragraph has been broken down into 35 words, and then when so many millions and millions of sentences and paragraphs are used in training the model, AI model will start to understand how actually the sentences are being constructed using just the words. And then when you ask it questions, it will be able to construct its own sentences. This is how NLP works. So we have seen how data works as input, how images and videos work as inputs, and how the text in the form of audio or in text works. But we saw at the beginning of the video itself that actually in any application, two or more of these domains would combine. For example, self-driving car would use CV and data. Video captioning would use CV plus NLP because it will see the video, and of course it cannot see it with its eyes, but that is how Let's Speak. For better understanding, it will see the video and translate the audio and put it as caption. Then a voice camera assistant would listen to you. That is NLP. It will recognize a scene computer vision, and it will log the data for improvement. So that is the data domain. So real AI is actually work and collaboration between all these three domains. Now let's come to a small mini activity that I said at the beginning that I would be giving you, and I would like you to actually do this to understand how the algorithm is actually trained, how these three domains work. If you want to pick up the data domain, so you can run a quick class survey and ask students to list their ages or their height and their weight and make a quick chart. So then you can identify a pattern, that what is the average height, or what is the average weight, what is the average marks, which is the highest marks, which is the lowest marks. You can see that. If you want to do a project in the computer vision domain, then you can take a few images and count how often a common object appears. Maybe pick up a book and choose a chapter and look at all the images and see which objects are appearing repeatedly and count them. So you're counting the appearances of those images. That would do for a CV project. If you want to use NLP, then you can paste a short news paragraph into a word cloud tool. Just go to Google and type in free word cloud tool, and it will build the word cloud from that paragraph that you have pasted, and you can notice whatever are the most frequent words being used there. So these are just ideas that I had, and I would want you to do it in the class so that you can actually understand how data scientists are working and imagining the system to work. All these you can do on paper. If you have to make a chart, you can draw, or you can count manually, or you can highlight the repeated words, make a circle around them in the news paragraph itself. It is not necessary that you have high-tech equipment, laptop and computer and scan to work with these projects. The idea behind these projects is to make you understand how the AI input works. So that was all for today's video. Let's just wrap up. Data domain turns numbers into predictions. Computer vision understands images and videos to recognize and locate things. NLP would take text and speech as input and understand it and respond to your queries based on that. Most AI applications blend two or more of these domains. So that was all about this video. In the next video, we'll be talking about how AI supports smart living. That is smart homes, smart cities, smart schools, smart hospitals, and more. So that was all for today. If you have any questions, don't hesitate to ask in the comments, and I promise I'll answer it. If you found this useful, please subscribe. If you think someone else could benefit from this video, please share with them. And do not forget to press the bell icon so that you are notified as soon as I upload my next video. That's all for today. Thank you. Bye-bye.